Tell me. Yeah. What we do in this cumene hydroperoxide method? Yeah, Vamsi. Clear? What we do?
So we oxidize and react it with H plus.
No, actually, first we. So sometimes it is given directly cumene. What is the other name for cumene? Cumene is actually isopropyl benzene, right?
Yes, sir.
In isopropyl benzene, what we do here is we can prepare it by many ways. We can take isopropyl chloride, benzene, and what we need to take along with it so that we can end up with the cumene. How can we get the cumene or isopropyl benzene if we take isopropyl chloride and benzene? Yeah. Which reaction is this? This is your Fieldcraft alkylation. Okay. What you do here is you take AlCl3. Okay. AlCl3 will abstract the Cl minus, right?
Yes, sir.
And once you abstract the Cl minus, what happens is this you will end up with a cation, and that isopropyl cation comes and join in on the benzene ring, and your H plus get removed, right?
Yes,
Is it
sir.
clear? And then you react it with oxygen in the presence of light. Okay, clear?
Yes,
So
sir.
which hydrogen will be abstracted by with most ease? Which is the most easy to abstract? Yeah, tell me.
So I didn't get your point.
Actually, which hydrogen will react in this reaction?
So the 3-degree, the hydrogen which is attached to 3-degree carbon.
Yeah, tertiary hydrogen will react, and this H will get abstracted. Okay, and you will have this. Okay. What is the name of this compound? This is cumene hydroperoxide, because on one side you have a cumene, which is isopropyl benzene, and on another side you have H. So cumene hydroperoxide, right?
Yes, sir.
Okay. So now what you do? Actually, this H is most reactive, so it gets abstracted most easily, right? So that's why the oxygen get attached. You break the H, the oxygen will get attached to the cumene and OH. Okay. Now the next thing is what you do after this. Yeah, what you can see over here is, you can tell me.
So we react it with a polar protic solvent and it becomes
Yeah,
phenol and
yeah,
acetone.
we react actually with the which conc H2SO4. Okay. So H2SO4 actually what it does is it removes the OH, protonates it, it removes it, and the phenol get transferred to the oxygen. Okay. So actually there is a rearrangement happen. right?
Yes, sir.
So this OPH and the water comes and join in again in this. And this compound actually breaks into phenol and acetone. This is phenol and that one is acetone, right?
Yes.
Clear? So phenol and acetone you get. So acetone is a byproduct. Okay. So that is asked in many on most of the JEE questions, NEET questions. This is a very, very common thing. So tell me, what will be the answer to this problem?
So option C.
It is option C. Yeah, A is that cumene hydroperoxide, correct? Yeah, it is option C. And what about this one? Yeah, this is also
So option
somewhat
C.
option C. Yeah, actually you have taken normal propyl benzene, but it will undergo rearrangement. Okay, the cation will form here, but it will come at this position because it is secondary. And it is going to join from this, so it is isopropyl benzene, and then right, that is P, and you have option C. Yeah, part of it is correct. You need to select the right answer. Yeah, just check it quickly. C or D?
No, no such D. It is not
Yeah, it's
acetone.
D. Yeah, because it is acetone. Yeah, correct. Acidic strength, alcohols are acidic in nature. And how the acidic strength of aliphatic alcohol is going to change? So you have more and more alkyl group, it is going to become less and less acidic, right?
Yes, sir.
Because alkyl groups are electron donating and it will become O minus. The O minus will become less and less stable because you don't want the electron to uh, get attracted towards the O minus, right? So you
Yes,
need
sir.
electron withdrawing group. Electron withdrawing group will increase the rate, increase the acidic strength of the alcohol. And alkyl group, actually the number of alkyl group, if you have more alkyl groups, okay, for this bond, always remember for this bond, the ease is more for primary, secondary, and tertiary. Okay, clear? So as you have more and more alkyl groups connected, it is becoming less and less acidic, and once it becomes less and less acidic, you have uh, higher and higher pK values. Okay, the pK of water, that is 15.7, and if you have alcohols, its pK is going to be higher, except methanol. That is the exception. Okay, clear? So phenols are slightly more acidic than water. Why?
So due to resonance.
Yeah, due to resonance. So phenol pK is 10, that we can see. And once you have nitro group, the acidic strength increases, the pK decreases. Okay, clear? So just one thing which is many times it is asked. Can you tell me the acidic strength of phenol? Orthonitrophenol, metanitrophenol, paranitrophenol. Yeah, acidic strength.
So paranitrophenol is greater than orthonitrophenol, and then meta, and then phenol.
Yeah, yeah. Para, why para? Why
So
not
there's no
ortho?
intermolecular hydrogen bonding
Yeah,
happening at
yeah,
para.
intermolecular hydrogen bonding. Yeah, correct. So that nitration, you need to take dilute H2SO4. Why? Why you don't take conc H2SO4 and HNO3? Dilute
So
HNO3.
concentration, I mean, oxidation takes place.
Yeah, actually oxidation and the multiple places it can happen. Okay, phenol is already activated, right? And it can get oxidized. So that's why you take, and same is the case with other reactions also like halogenation. Okay. So for suppose if you take Br2 and CS2, you have only one Br connected, either at ortho or para position. But if you take Br2 and water, you have a lot of Br connected at all the ortho and para positions. Why? What's the reason? And this is
Not
also
sure.
a test for phenol. It is white PPT. Yeah, it has changed. Just a second. Yeah, that is white PPT. So what's the reason?
Not sure, sir.
Actually, what happens in carbon disulfide is a non-polar solvent, so phenol doesn't ionize, and in water it ionizes, it becomes phenoxide ion, and which one is more electron rich? In carbon disulfide, it remains phenol only. Okay. In water, it get ionized. Why it get ionized in water? Yeah, what's the reason?
So because it's a polar protic solvent.
Yeah, it is a polar protic solvent, and actually, yeah, it is polar, so it facilitates the ionization, and that's why. So it is very rich. Okay, Memuna, can you hear my voice? Yeah. So this is Rimmer-Timon reaction. So just we were discussing. So Rimmer-Timon, okay, just we can do some questions. And what is the change in molecular weight of phenol observed when you carry out its Rimmer-Timon reaction? Yeah, how much it will be? So I hope you understood the question, both of you, Memuna and
Yes,
Vansi.
sir.
Yeah. So tell me. What's going to be the answer to this one? Yeah, just quickly. You can do it very fast.
So it will increase.
Yeah, it will increase, but what is the value? Suppose if I give you 14, right? Or if I give you some options like 29 or 28 or 32, what's going to be the answer? Yeah, Mamuna, is it clear? The question is clear now.
Yes.
So what's going to be the answer? Yeah. Yeah, Vamsi, tell me.
Just a second, sir. I'll just calculate.
Yeah. So in this whole cycle of Riemann reaction, what's going to be the change in molecular weight? Okay. So, yeah, Mamuna, any option?
Sir, option C, the third one.
Yeah, third one. Actually, what is there? Just you need to, because H was already there. Everywhere you have H, the phenol is already same. And this H was already there. Okay, this portion was already there. Only CO extra is added. Okay, and because CO is added, so you need to, so whatever the change which is observed in this, so that is because that is only due to CO. So you need to consider only the molar mass of CO. That is 12 plus 16, right? And it is going to be 28, right? Okay, yeah. And this is also a very famous question. This is OCS3 group. Okay. And when you do the Riemann reaction of this, what's going to be the product? In case of any doubt, you can ask me or stop me. Memuna, Vamsi.
Okay.
So actually, Riemann is formylation of benzene. Okay, it attaches CHO group to the benzene. Okay. So what is going to be the answer to this one?
So third option.
Third option. And Memuna, what's your answer?
The second one.
The second one will be the right answer. Why? It is because actually you are doing it in NaOH, and NaOH is going to replace the H plus from the OH. Okay, so OCS3 between OCS3 and OH, OH is more electron rich because it becomes O minus. Okay. And when it becomes O minus, it undergoes resonance more strongly than the resonance of OCH3 group. So it makes the ortho and para positions more negative. So first thing is you need to put the CHO group at the ortho and para position, right? Now the next thing is that if any one of the ortho position is occupied, then para is a major product. Suppose if ortho positions are not occupied, then there are two ortho and one para. But if ortho positions are occupied, for let's say in this case, so now ortho, there is one ortho and there is one para. So now you will choose the para, okay, more. There it can happen more quickly. So this, and para with respect to whom? OH or OCSC? OH, because OH is more activity. So I hope it is clear. And Memuna, I think you must, you might have used the same thing to answer this question. Okay. Yeah. Vamsi, have you understood? Let's do one
So-
more question.
So due
Yeah.
to NaOH, the ring gets activated, right?
Yeah, because the H plus will get removed, it will become O minus, and O minus is highly activated. Right?
Yes, sir.
And there is one more thing. If you have any ortho position occupied, then para position, then the Riemann reaction is going to occur at the para. Right?
Yes, sir.
Now this is the next question, and then this is NaOH, and this is A. And then you have used and B. So what's going to be the answer of B? Option 1. Yeah. So what is the common name of this molecule? Yeah, Memuna, what's the common name? Vamsi? You can try it quickly. So what is the common name of the phenol having two OH groups?
So dihydroxy, you know.
Yeah, but that is very common. There is a specific common name. Memuna, could you try? That is catechol, resorcinol, and quinol. Catechol is the phenol with two OH groups. Okay. And resorcinol is the two OH group which are at meta position, and quinol is two OH group which are at para position. Right?
Yeah.
Clear?
Yes, sir.
So you can try this one. Yeah, what's the answer? Any idea? Yeah, you can use the same trick which I told you. First of all, if any one of the ortho position is occupied, you need to connect the CHO group at the para position, right? Clear?
So option 2.
Yeah, option 2. But how this ring has formed? So you need to connect. So para of this Memuna is this one, and Vamsi the para is this one. So both are being symmetrical. You can connect to any one of them, right? But how you got this side of the ring? Yeah, Memuna, any idea? Actually, what will happen is in the basic medium, this is basic medium, you know, and the two HR groups are going to get abstracted and it will become O minus and O minus, right?
Yes, sir.
Okay. And what you have taken along with it? In the second step, you have taken CH2I2, right? So this SN2 is going to happen. One I will come out. This O minus is going to attack again. The another I will come out. So what is going to form? Is it clear? Okay.
Yes, sir.
So B is going to be the answer. Second option is going to be the answer. Yeah. And this is very simple question. Very, just a very simple question. Yeah, what's going to be the answer to this one?
Option B.
Option B, no, not the formal cation. Not option B.
Option C, I guess.
Option D. Actually, what happens is, first of all, what happened to phenol? It is actually the phenol is actually the in the basic medium, so it will turn itself to phenoxidine. That is one thing. Okay. And the phenoxidine, you can write it like this also because it is in the resonance, so minus charge is going to come at ortho and para positions. Okay. Another thing is what happens at this chloroform. So chloroform, first thing which happens is you have taken a base and this base first of all abstracts the H plus. So H plus is abstracted, it forms C minus CCl3 minus. So this is one of the intermediate. Okay. And in second step, what happens is the Cl is a good leaving group, it also comes out. And already there is a minus. And when Cl comes out, it forms CCl2. A lone pair remain as such, which came by the removal of H plus. So it is the dichlorocarbene. Okay, very, very important, right? You need to remember it. Very important that the intermediate is dichlorocarbene. Okay, but this is not the only intermediate. Suppose if someone asks you, this is also the intermediate, this is also the intermediate, right? And once it is dichlorocarbene, this is a neutral species. Okay, but that doesn't mean that it is not reactive. It is highly reactive because it has only six electrons. You can see there are 2 bonds and 1 lone pair. So it is highly reactive. So what it acts like an electrophile. So normally in most of the EAS reaction, the electrophile used to be of this type, which Memuna said first option. Okay, but in this the electrophile is different. So what happens here is this electrophile comes and join itself to the minus, right? H and CCl2 minus. This minus takes away the H. The electron get back into the benzene. So again it becomes O minus and this becomes CH. So all this is also an intermediate. Okay, there are a lot of many intermediates. CH. This is an intermediate. CHCl2. And finally what happens here is the OH minus hydrolyze this both Cl, they are removed and finally it changes to CHO. There will be 2 OH groups on this, right? So 2 OH groups will get removed and you will end up with CHO. So this is again, this another intermediate is going to be this one. Water will be removed and you will end up with CHO. Okay, so all these are the list of intermediates. So this is a complex mechanism, so it doesn't in this we can't have only one intermediate. Okay, lot many intermediates are there, right?
Yes, sir.
Clear? Memuna, is this clear?
Yes.
Okay, so this is a similar reaction which is Kolbe's reaction, and it looks very similar to the Riemann, but it is not Riemann reaction. It is different. Okay, so you take CO2 and you will end up with this. So what's going to be the mechanism? Quickly we can discuss. Very easy. The phenol changes to O minus. Okay, and O minus because of resonance it will come at ortho or para. Why I'm preferring ortho position? Because ortho positions are 2 and you will have, and this minus, okay, is a nucleophile and it will attack the CO2 molecule, right? Vamsi, is it clear?
Yes, sir.
And you will have COO minus. And you will have H plus removed, that will get back, the electrons will get back into the ring and you will again have that phenol and CO. So that is salicylic acid. Right? Formed. But what is the other set of reagent which can be used to convert the phenol to this? Yeah. Yeah. Memuna, Vamsi, tell me quickly.
So can you repeat?
If I don't want to use NaOH and CO2, what else can I use here? And that is not
So
the Cold-based
CHCl.
reaction. Which one? What we can
So the
use?
so CHCl3 and NaOH, the previous one.
No, but CHCl3 actually you will end up with CHO. Okay. Yeah, Memuna, any idea? It's there in the NCRT also. So it's very important because either you do NEET or JEE and they follow NCRT very strictly. But superficially, if you read it, you will not be able to get the answer. You need to read it in depth, each and everything. Okay. So it is not CSCl3, it is CCl4 and NaOH. Is it clear?
Yes, sir.
But this is not coal-based reaction. The name is not coal-based. Coal-based is if you use only CO2. Okay. If you use chloroform, you will end up with aldehyde group CHO. If you use CCl4, you will end up with carboxylic acid. But this is the other way to do this. So there are two ways. Either you take NaOH and CO2 or you take CCl4 and NaOH. Clear? So both will give COH because you will have, so after attack, you will have 3 Cl left and 3 Cl will change to 3 OH group and 3 OH group upon hydrolysis, upon removal of water, they will give COH. Okay. Any doubts in this?
No, sir.
Memuna, is it clear? Anything needs to be explained, you can tell me. Now the reduction of phenol, how can you reduce the phenol? Okay, by using zinc dust. That is the only method. Okay. We have seen so many methods for the preparation of phenol, and if you use zinc dust, you can get back your benzene. Okay, so this is very important, you need to remember it. But if so, this is the reduction, and oxidation is if you use any strong oxidizing agent, sodium dichromate and H2SO4, so it will change to quinone. Okay, clear? So this is just you need to remember. So let's do this question. And what's going to be the answer to this one?
Sir, tolling? No, sir.
This is part of it, and we have studied now, and part of it in 11th class.
Sir, benzaldehyde?
Memuna, what's your answer? Yeah, benzaldehyde. And yeah, we're very close. So what is X? That is clear. Yeah, Vamsi.
Yes, sir, it's clear.
X is benzene. Okay. And Y is also clear. What is Y?
Tolling.
That is toluene. Right. And one thing which you need to keep in mind is, suppose if you oxidize any side chain on the benzene ring, any alkyl side chain on the benzene ring, any alkyl side chain of the benzene ring, listen very carefully, irrespective of the number of carbon atom, it get completely oxidized to COH. Okay.
So can you repeat?
Any alkyl side chain of the benzene ring upon oxidation gets oxidized to COH. Suppose if you have one methyl group, one ethyl group, and you have one propyl group. Okay, and what will happen if you treat it with KMnO4H plus heat or K2Cr2O7H plus heat? What will happen? What you are going to get? Yeah, yeah, Vamsi. One methyl, one ethyl, and one isopropyl or propyl group. So irrespective of the number of the carbon atom, you have one, you have three carbon, you have two carbon, they all will get oxidized to COH. Is it clear?
Yes, sir.
So you will have three COH group left on the benzene ring. Okay, clear? So this is very, very important, right? So in this case, there was only one methyl group, so you will end up with benzoic acid. B is the right answer. Okay. And which is this reaction? Acetylation. What do you mean by acetylation? Yeah. You remove H and you put acetyl group. So if you take an alcohol and if you react it with an acetylating agent is acid chloride. Okay. This is one acetylating agent. The other acetylating agent is acetic anhydride. Okay, so in acetic anhydride, you end up with this whole thing get removed. Acetic acid molecules is removed. And in acetyl chloride, if you take, you will have HCl removed. Is it clear or not? Memuna Vamsi, tell me quickly. So the OH get acetylated and you end up with an ester. Is this clear? This is very important reaction. Though very simple.
Yes, sir.
Acetylation reaction. So it can be any aromatic alcohol like phenol. Not necessarily it should be aliphatic, it can be aromatic. Or it can be aliphatic alcohol. And you will have this acetic anhydride and it will get removed. And the H will be replaced by OCOCH3 acetyl group. That is called acetylation. And acetylation reaction is very famously used for the preparation of aspirin, right? So aspirin, you do the acetylation of OH group by taking acetic anhydride and you end up with your aspirin. What is the IUPAC name of aspirin? Can you tell me? Yeah. IUPAC name of the aspirin. And what questions are asked related to acetylation, that also I can quickly tell. So first thing is, what is the, so they in the school viva also, in practicals also they can ask. Yeah.
So 2-acetobenzoic acid.
Yeah, 2-acetoxy. This is acetoxy. Okay, 2-acetoxybenzoic acid. That's the IUPAC name of aspirin. Aspirin, how it is obtained from the phenol. So phenol, first how can you convert phenol to aspirin? Phenol, and what you need to do. And just now we have seen one reaction.
Just CCl4.
CCl4 and NaOH. That will give salicylic acid, or you can take Kolbe's reaction, Kolbe-Schmidt reaction. That's the complete name. So that is, you are going to get salicylic acid, and once you have the salicylic acid, you can take CH3COCl, or you can take CH3C double bond OOCOCH. So this HCl will get removed, okay, or H and OAC get removed. You will end up with acetylated salicylic acid. That is aspirin. Okay. Now let me ask you a very, very important question. What's the use of acetylation? Which other function group undergoes acetylation? Very important. Yeah. And this use is also applied in your biomolecules chapter. So have you studied biomolecules now
No, sir.
in your boards? For your boards, yeah. So actually what happens is, so the question is, acetylation, actually alcohol undergo acetylation? And amines also undergo acetylation. Is it clear? Why amine can also undergo acetylation reaction? Because they also have that lone pair, right? They can also come and they can also react with the CH3 COCl. Okay, so, and amine also have that. Amine actually are more basic, so they also undergo acetylation reaction. This is one thing. The next thing is, if you do the acetylation, what will be the change in molecular weight observed? This question is also asked many times. Yeah, same question which we discussed today, same type of question, but not same. Yeah, Memuna, any idea? You can calculate quickly, but you need to remember it. But that's very important. Why it is important, I'm going to tell you. First of all, you can tell me what is the change in molecular weight observed if you do the acetylation.
So 42.
Yeah, it is 42 per OH. Change in molecular weight will be 42. Okay. So where it will be used? Actually, it will be used to estimate the number of OH groups. Okay. So suppose if you take glucose molecule, glucose is this one. So Upon acetylation, what will be the change in molecular weight observed for glucose? Yeah. Or 1 mole of glucose will consume how many mole of acetyl chloride? With that you can use. Yeah, Vamsi. Femina, you can also try and answer me.
Yeah.
Yeah. So this is a question which will be useful in your biomolecule chapter also. This serves as an evidence for the structure of for glucose and fructose. Yeah.
Not
Yeah,
sure, sir.
Vamsi. Yeah, Vamsi. No, actually there will be 5 OH group, no? So how many acetyl group are needed? N will be equal to 5, right? Very simple. Okay. And what will be the change in molecular weight observed? Yeah. You said for one OH group it was 42, right? So for 5 OH group, it will be how much? It will be 210. 42 into 5. Is it clear?
Yes, sir.
So what they will do, they will suppose they will give you the reverse question also. Okay. So this is very in JEE advanced also they have asked. In NEET also, because it is a very common concept and used in carbohydrate also. Okay. So suppose if you have a compound which upon acetylation, the change in molecular weight which is observed for that compound is 126. Is it clear? So how many OH groups will be there? They will ask in this one. The number of OH group, or they will write the structures which structure is expected. Yeah. So you can, what you can do is change in molecular weight. You can divide it by 42. Okay. So you will get 3. And from that you can make out there will be 3 OH groups. Is it clear?
Yes, sir.
So it is acetylation is used to find out the number of OH groups in a molecule, and that serves as an evidence for structures of carbohydrates. Carbohydrates, glucose has 5 OH. How you are going to prove it? The glucose has 5 OH. You do acetylation and there will be an increase in molecular weight of 210. Okay. Right? From that they tell. Okay. So now the next thing is reaction related to active hydrogen, means acidic hydrogen alcohols are not that much acidic. And just now we have seen that the primary alcohols are out of the primary alcohol and secondary primary are more they are not, I should not say that they are acidic like HCl, or but they can prime out of all the types of alcohol, primary can give H plus more easily. Is it clear?
Yes, sir.
Tertiary actually give H plus with bit difficulty, and because they are more electron donating. So if you have more electron donating group, the O minus is going to become unstable, and alcohol acidic strength decreases, right? So that's what we have seen. So but this can be used to detect the alcohol. Okay. But how can you detect the alcohol? But this is not the universal test you can which you can apply for all type of alcohol, but just it can tell you whether it is an alcohol or an ether. So suppose if you have C2H6O, they will say it like this, and if you put sodium and it releases hydrogen gas is liberated, means it is an alcohol, right? And if you put sodium and no H2 gas is liberated, liberation is observed, means what? Means it will be which molecule? Yeah, tell me. Pamsi, Memuna.
So not alcohol.
So which one? If it is not alcohol, then which one? Which is the other isomer of alcohol? Yeah. Which is the other isomer for of alcohol? That is ether. Is it clear?
Yes, sir.
So it is going to be very simple. So it can this test reaction with sodium and liberation of H2 gas will not tell you the in-depth details about the structure, but it can tell you only whether it is an alcohol or an ether. Okay, clear?
Yes, sir.
So ethers will not liberate hydrogen gas, alcohols will liberate H2 gas when reacted with sodium or aluminum or active metal. Okay, and and phenols, right? Phenols actually will are more acidic. Ethers will not liberate this gas. Okay, so phenols also will liberate sodium. But there is another thing where we are going to use it, and it is also used for separation. So listen to me very carefully. So here you use Na, okay, which is a metal. Clear? So metals are very reactive. So metal is going to react with all, either alcohol or. But if I ask you which one is soluble in NaOH, is it the aliphatic alcohol soluble or phenol which soluble in NaOH? This is not Na. Be careful. This is NaOH. Yeah. Yeah, Vamsi, Memuna, what's the answer? Quickly tell me.
So phenols more soluble.
Yeah, phenol is soluble. I'm not telling who is going to react with sodium. Both are going to react with sodium. Okay. Sodium is very reactive. So sodium will react with both of them. So I'm not asking that. I'm just asking that which is going to be more soluble. Or if I ask you, how will you separate alcohol from phenol? Okay. So what you are going to do? You are going to put NaOH, and this phenol, because it has more acidic hydrogen, it will undergo acid base reaction. And it is going to form a salt. On the other hand, alcohol will not react appreciably with NaOH. So they will not form a salt. Right? And what you do, you put water. So this will be water soluble and this will not be very much soluble. Okay, water and ether you can take. Right? So you can separate by reacting with NaOH. Okay? Clear? Now the
Yes, sir.
next reaction is acid catalyzed dehydration of alcohol. So let me tell you one more thing. So wherever you are going to break RO bond, the RO bond is going to be broken in this manner. So rate is directly proportional to the stability of carbocation. Clear? So tertiary, secondary, primary, and methyl. Is this clear?
Yes, sir.
So which alcohol is going to undergo dehydration most easily?
Tertiary.
Tertiary alcohol. Yeah, and you can check but the temperature also. So at what temperature ethanol undergoes dehydration? With concentrated H2S. At what temperature ethanol undergoes dehydration? Yeah,
443 Kelvin.
yeah, 443. Yeah, it is. You can remember around 170 degrees Celsius. And if you take 140, the dehydration will not occur. Right? The tertiary
Yes, sir.
alcohol is going to dehydrate more easily because the cation, the H plus will come at the OH, it will form OH2 plus. It will come out as water. Cation is formed, and from the cation, the H plus is removed, and that lead to the formation of an alkene. Okay. So that's how the elimination occurs. But the main RDS or the slowest step is the formation of cation. So if you have a more stable cation, means the whole reaction is going to occur very, very quickly. Is it clear? So the main step is the formation of a cation. Okay, and these are the temperature which you should know. They are there in your boards also, and they are asked many, many times. Okay, is it clear? So elimination require high temperature because you are forming an alkene. So always for ethene, this is not the temperature for every alkene, because if you have more and more branching, the alkene is going to form more and more easily. For ethene, if someone asks you, it is 170, but what will happen if you take 140 degree? In 140, elimination alkene will not form. You will have an ether. Is it clear? Ether
Yes,
form,
sir.
C2H5. Okay, and if you take much less temperature, 110, you will have this. Okay, is it clear? So the mechanism is always get protonated, cations form, and there is a elimination from of H plus from position adjacent to cation, which leads to the formation of an alkene. So let me ask the question. Concentrated H2SO4 you need to take because it absorbs water, and that is can lead to removal of water most easily. Yeah. So what is the IUPAC name of the product? Yeah, Memona. If you are here, you can tell me. Vamsi.
Yes, sir. Just now.
What's the IUPAC name of the product? It is going to be an elimination reaction. But straightforward, you can't get an alkene. You need to do something, and from that you need to get the alkene. Yeah. Yeah, Vamsi, what's going to be the answer? Memuna,
So 2-methyl butane
2-methyl butane,
2-ene.
2-methyl but 2-ene.
Yes, sir.
So, yeah, how it is formed? First, will have OH removed
Yes, sir.
by
Then there'll be
protonation. You will have a cation. Yeah. Then,
so the since it is unstable, there'll be a change in the position, and then
yeah, there will cation have always have tendency to rearrange if they become more stable by moving on to the adjacent position. They will move. Okay, and you will end up with a new cation. The next thing is now the H plus last step, which is a fast step. Okay, the H plus will be removed from the position adjacent to H cation. So you will have this. You can have this alkene, or you can have this alkene also, right? Is it clear? So which alkene is
yes,
going
sir.
to form in a major amount?
So the second one.
Yeah, why? What's the reason? Yeah. What type of alkene is this? Setzef alkene. Okay. And this one is often less branched alkene. Is it clear?
Yes, sir.
So what's going to be the rate of dehydration? Yeah. Very, very basic question. How easily these alcohols are going to undergo dehydration? Yeah. Yeah, Vamsi, Memuna, tell me quickly. How easily the dehydration is going to occur? What is the RDS? What is the main step? The main step is the removal of OH and the formation of a cation. And if the cation is very stable, definitely it is going to form very quickly. Okay.
So SRQP.
S is S, R, Q, and P. Whatever you thought is correct, except one thing. R, Q, P. That is correct. But S is not. S will not undergo dehydration. Why? What's the reason?
So the carbon oxygen bond is, it's
Yeah, it's double bond.
double bond.
Yeah. So it can't come out so easily, right? That's the reason. And you can't have that alcohol if it forms the cation, if it forms, it is going to be very unstable. Okay. It's going to be very unstable because you need to have a cation and double bond adjacent to the cation, then it will can undergo resonance. But in benzene, so some people may say, okay, look, there are so many double bonds, but it is of no use because already the double bonds are there and the OH is in resonance. And if you make this cation, it will not undergo resonance, right? It will be highly unstable, right? So you need what? You need to have a cation and a double bond adjacent to the cation, then the cation can undergo resonance, not this one. Okay, so this is going to be the answer. Okay, is it clear?
Yes. Yes.
Yeah. Okay. And this is a basic question. You can try it quickly. Yeah. Yeah. What's going to be the answer to this one? Memuna, 3,3-dimethyl butane 2-ol. This one. Pharmacy. What's going to be the answer? Yeah. Yeah, Memuna. Pharmacy. What's
So
going to be
it's option
the
D.
option D? 3,3-dimethyl. No, no, no. Just now you told. You forgot to do one thing. You forgot, just missed one thing. Yeah, Memuna, you can try. Yeah, Memuna. Vamsi, yeah. What you forgot? Tell me. You forgot to do the rearrangement. Is it clear?
Yes, sir.
So now tell me what's going to be the answer. So cation has a tendency to become more stable if it is moving on to the adjacent position. Yeah. Yeah, what's going to be the answer to this one? So you will
Yes, sir.
have
It's option C.
it's option C. Yeah, 2,3-dimethyl but 1 in. Again, you made one mistake, though you made the rearrangement. This is the cation. There is going to be one methyl group shifted onto this cation.
You said double bond on second carbon, so it's A.
Yeah, it's a, yeah. So it's the cation which is going to come here. So you can have a Setzef alkene and Hopfen alkene, right? So more branch alkene is going to be more stable. Okay. So that is going to be the major answer. Now the
Sir, can you
next one,
scroll up once?
yeah, yeah.
Okay, sir.
Yeah, so this is basic question, very common one, most common one asked in all the examination, standard question. Now this one, oxidation. Okay, so first of all, if you oxidize, so what is oxidation? Removal of hydrogen, right?
Yes, sir.
And or addition of oxygen, that we know. And suppose if you oxidize primary alcohol, what are the options are there with you? What are the options with respect to the product? What functional group can form upon oxidation of a primary alcohol?
Aldehyde and carboxylic acid.
Aldehyde and carboxylic acid. Yeah, when you will end up with an aldehyde, when you will end up with a carboxylic acid.
So when you're using a strong oxidation reagent, that time it will become carboxylic acid, and if you're using a mild one, it's aldehyde.
Yeah, for mild one, it's going to be an aldehyde, and for a strong, you will directly end up with a carboxylic acid. So which, and but for secondary alcohols, yeah. What about secondary alcohols? Secondary alcohols, they get oxidized only to the one level. They get ketone. Ketone do not get oxidized normally. Okay, until unless very strong conditions are used. So just you will end up with ketone. And what about tertiary alcohols?
So that is also ketones and
No,
acetone, I think.
no. Tertiary alcohol will not undergo oxidation. Why? They do not get oxidized. Why?
So the primary carbon has no hydrogen.
Yeah, the carbon has no hydrogen. That's why. Okay. So for secondary alcohol, you will end up with a ketone only. Okay. For primary alcohol, you have two options. So primary alcohol, you need to be very, very careful. That's where everybody make mistake. In primary alcohol, you can either end up with an aldehyde, and aldehydes can get oxidized further. This H can get oxidized very easily to OH. Okay. So what are the mild oxidizing agent which can actually, these need to be discussed, which can stop at aldehyde? Yeah.
So PCC and PDC.
Yeah, PCC and PDC, but you need to keep one thing in mind that you don't have to take water. Okay, because if you would have taken water, PCC, what is the solvent with PCC? It is CH2Cl2, right? And if you take water, then it will get then the whole purpose of taking mild will be defeated. It will change to carboxylic acid in water. Another mild oxidizing agent is copper red hot tube, copper 300 degrees. This is very common and given in NCERT. Okay, these are mild, right?
Yes, sir.
So I hope this is clear. Okay. So let me. And strong. What about strong?
Sir, I think acidic KMNO4.
Yeah, either K2CR2O7 Acidified potassium dichromate or acidified potassium permanganate. KMnO4.
Nitric acid.
And nitric acid also. Yeah. Yeah. Correct. So what's the change which you observe? Suppose if I give you a test tube in this, it is a primary alcohol. And there is another test tube where there is a tertiary alcohol. And if you put this reagent, let's say, what change, because this is very, very important thing, because this is going to be a common reaction from your NCRT, or it can be asked in the way in which I'm asking, it can be asked in your competitive examination. Right. So what change, color change will you observe? Yeah. Yeah, Vamsi.
So it will turn, I think, purplish color.
Mm-hmm. No. And what's the original color of this? This is there in our D block also, in class 12th itself.
Not sure, sir.
Yeah, this is orange color. Bright orange color compound. Very intense orange. Okay. And what happens? The alcohol get oxidized to carboxylic acid. Okay. And this is a redox reaction, and you know that redox reaction only oxidation doesn't happen. Clear?
Yes, sir.
There is someone who will get reduced. So who will get reduced?
Carbon.
Is chromium, not carbon. The carbon get oxidized. So dichromate is going to get reduced to chromium plus 3. What's the oxidation state of dichromate initially? Oxidation number of chromium plus 6. Right?
Yes, sir.
And it was orange and it will turn to green. Is it clear?
So for primary, right?
Yeah, for primary and secondary also. So whosoever get oxidized by dichromate, you will observe green color. Not only in alcohol, primary alcohol, secondary alcohol, in every reaction, you must be doing salt analysis in the school. Are you doing it?
Yes, it's over.
It's over. So which one you? So dichromate and all, they are there, right?
Yes, sir.
So dichromate, it is going to give you green color. So be careful. Dichromate is there, I think, in the syllabus, because it is there in the NCRT. Even if you don't do the practicals, it is there in the NCRT also as D block in theory, right? So be careful about it. So it is going to give you green color. And what about this one, tertiary alcohol?
So it won't react.
Yeah, it won't react. So what color change will you observe?
So there will be no color change.
No color change, exactly, and it will remain orange, deep orange color. And what is the change which you observe for KMnO4? Yeah.
So it will turn red for tertiary.
No, KMnO4, you must have done your titration also in the school. KMnO4 and oxalic acid. Yeah. Actually, KMNO4 is intense purple color, pink purple color, and it will change to Mn2 plus. That is colorless. Okay.
Yes, sir.
Clear. So do, but you can test the alcohols only if one is the such